You begin by resting your attention on the ground beneath you. Not the floor of your room, not the walls, not the roof, but the deeper ground, the ancient foundation under everything you know. You let your breathing slow, and as it does, you imagine that the planet itself is breathing too. Not quickly, not loudly, but in a rhythm so vast and patient that it hides inside silence. You are used to thinking of Earth as solid and still. A dependable stage where life happens. A fixed platform under your steps. But now, in this quiet moment, you allow a different idea to gently unfold. The planet is not frozen. It is not locked. It is moving, always moving, in ways too slow for your eyes, yet powerful enough to raise mountains and open oceans. Picture a single fingernail growing. You never see it happen, yet over days it changes. Earth moves like that, subtle, continuous, unstoppable. Beneath your feet lies the crust, a thin outer skin of rock compared to the vast body below. If Earth were the size of an apple, this crust would be thinner than the apple's peel. And yet everything you know, forests, cities, rivers, roads, your home, your resting place, exists on this delicate outer layer. It feels permanent to you because your life is measured in decades. But the planet measures time in millions of years, and in that long clock, the crust drifts like cloud shapes in the sky. You imagine the continents as great stone rafts. Not floating on water, but resting on deeper, warmer rock that can slowly bend and flow. This deeper layer is not liquid like a sea, but it is soft enough, under pressure and heat, to move over time. Scientists call it the mantle, but tonight you can think of it as a thick, warm cushion, a slow-moving foundation that carries the broken pieces of the crust above it. You do not feel this motion because it is gentle beyond perception. About as fast as your fingernails grow. About as fast as hair lengthens. Only a few centimeters each year. The width of a coin. The pace of patience. And yet, from such small motion come the largest features on Earth. You let that thought settle like a blanket. The mountains you have seen in pictures, or maybe with your own eyes, are not decorations placed on the surface. They are wrinkles formed by motion. The continents drift, meet, press, and slowly fold upward. Rock lifts against gravity grain by grain, layer by layer, century after century. What looks eternal is actually the result of movement. Even the quiet plains, the rolling hills, the deep ocean floors, all are part of this slow choreography. You imagine time-lapse vision now. The way a flower opens in seconds when filmed over days. In that same way, if you could watch Earth over tens of millions of years, you would see continents wandering. You would see shorelines reshape themselves. You would see collisions and separations like a silent dance of giants. But in your present moment, everything feels calm. Your body rests. The room is still. And this is the beautiful contrast. Motion does not always feel like motion. Change does not always feel like disturbance. Some of the most powerful transformations happen without noise. Deep below the crust, heat rises from Earth's interior. Some of this heat is left from the planet's formation, when gravity pulled dust and rock together and created tremendous warmth. Some comes from the quiet decay of natural radioactive elements in the rocks, releasing energy slowly, steadily, like a hidden hearth. This heat does not rush. It travels upward in gradual currents, transferring energy through solid stone. You can picture it like a lava lamp moving in extreme slow motion. Warmer material becomes slightly more buoyant and rises. Cooler material sinks. A cycle begins, not in minutes, not in hours, but across spans longer than the history of human civilization. These deep currents help guide the drifting plates above, like invisible hands beneath a tablecloth. You do not need to see them to trust they are there. Your breath moves in and out. The planet's heat moves up and down. Different scales. Same principle. Rhythm exists everywhere. You might wonder how humans discovered this motion if it is so slow and hidden. The answer is gentle observation. Careful measurement. Tiny clues gathered across generations. Coastlines that fit together like puzzle edges. Matching fossils found on continents now separated by oceans. Magnetic patterns frozen into seafloor rocks like barcodes of time. Each clue a whisper. Together, a chorus. Science often begins this way, not with a shout, but with a patient listening. You let yourself feel comfort in that. Understanding grows slowly, just like mountains do. The word tectonic comes from an ancient term meaning builder. A tectonic plate is not just a slab of rock. It is a builder of landscapes. A carrier of continents. A traveler with a load of ecosystems on its back. Your city, your roads, your fields, your sleeping place, all are passengers on a moving plate. You are gently traveling right now and you cannot feel a thing. There is something soothing in that idea. Motion without fear. Change without chaos. A reminder that stability does not require stillness. Balance can exist inside movement. You imagine the plates touching at their edges. Not smooth borders, but rough and complex seams. Like the stitched edges of fabric. These seams are where the most noticeable events happen: earthquakes, volcanoes, mountain building, but those are only the surface expressions. The deeper truth is ongoing motion. Continuous adjustment. A planet that never fully stops shaping itself. Even now, as you rest, the Atlantic Ocean is widening by a small measure. Elsewhere, another ocean is slowly shrinking. Somewhere, two landmasses move closer by the width of a grain of rice. It sounds impossibly small, and yet given enough time, it is enough to redraw the map of the world. You do not need to hurry to understand this. Let the scale remain vast. Let the slowness be part of the comfort. Tonight, you are allowed to think in geological time, where nothing needs to be finished quickly, where progress is measured in layers, where pressure becomes beauty, and where patience shapes reality. You rest on a moving world that feels still. You rest again in the idea that the ground beneath you is not one unbroken shell, but a collection of enormous pieces. Not shattered, not chaotic, simply divided with purpose. Like a mosaic whose tiles are measured in continents, whose seams stretch across oceans, whose pattern is always slowly rearranging itself. You imagine lifting high above the planet, far beyond clouds, beyond weather, beyond the blue haze of the atmosphere, until Earth becomes a sphere floating quietly in darkness. From here, the surface looks whole. Smooth. Continuous. But now, with gentle knowing, you soften your gaze and picture the hidden lines, the boundaries tracing across land and seafloor alike. These are the tectonic plates. Vast slabs of crust and uppermost mantle, locked together as single traveling units. Not thin sheets, but thick structures, tens of kilometers deep. Strong enough to carry continents. Broad enough to hold oceans. Patient enough to move without being seen. There are not hundreds of these plates. Not thousands. Only a modest number, like large puzzle pieces in a careful design. A few are enormous, spanning much of a hemisphere. Others are smaller, shaped like fragments between giants. Each one has its own direction, its own pace, its own long journey. You picture them now as rafts of stone on a warm, slow-moving foundation. They do not bob like boats. They do not tip with waves. They glide steady as drifting ice sheets on a polar sea. Your home rests on one of these plates. Your streets, your rivers, your familiar places all ride together on the same traveling slab. You are not crossing the plate. You are moving with it. It is comforting to imagine this shared ride. Everyone around you sleeping, waking, dreaming is carried in the same direction at the same quiet speed. A continental caravan measured in centimeters per year. Some plates hold entire continents and more. The African plate. The Eurasian plate. The North American plate. Names given not as ownership, but as reference, like labels on old maps. But these plates are not only land. Most include both continents and ocean floor together in one rigid body. Land and seabed are not separate travelers. They are bolted to the same moving platform. You let that idea settle, the ocean floor itself moves. It is easy to think of oceans as permanent bowls and continents as floating islands within them. But in truth, the seafloor is part of the plates too, created, moved, and sometimes destroyed as plates interact. The bottom of the ocean is not ancient everywhere. In many places, it is geologically young, far younger than the rocks under continents. You imagine drawing the plate edges with soft light. Some lines run down the centers of oceans. Some trace along mountain belts. Some cut through islands in curved chains. The borders do not follow countries. They do not respect coastlines. They follow physics instead: stress, heat, and motion. At these edges, plates meet like hands in different gestures. Sometimes they move apart. Sometimes they press together. Sometimes they slide past. But tonight you simply notice the shapes, the way the pieces neighbor one another in a shifting arrangement. Long ago, before satellites and sonar maps, scientists noticed something curious. The continents seemed to fit together. Not perfectly, but suggestively, like puzzle pieces worn at the edges. South America and Africa, especially, appear to echo each other's curves across the Atlantic. This was not proof by itself, but it was an invitation to wonder. Later came more clues. The same types of fossils found on continents now separated by oceans. Matching rock layers across distant shores. Magnetic patterns frozen into seafloor basalt, forming symmetrical stripes on either side of underwater ridges. Each discovery like a soft tap on the shoulder of understanding. You imagine the puzzle assembling in slow motion, not the plates themselves, but human awareness. Piece by piece, the picture becomes clear. The surface is mobile. The divisions are real. The motion is continuous. A plate is not defined by what sits on top of it: desert, forest, city, ice, but by how it moves as one body. Everything attached travels together. Mountains do not slide off. Oceans do not spill away. The plate is rigid compared to the softer layer beneath, so it holds its shape across immense distances. Rigid does not mean unbreakable. It means unified. You can think of each plate like a giant wooden board floating on thick syrup. The board stays solid, but it can drift, rotate, and gently bump its neighbors. The syrup beneath the warmer upper mantle deforms slowly, allowing motion without sudden collapse. The speeds vary. Some plates move faster than others. A few centimeters per year is typical, about the rate your fingernails grow. It sounds almost playful in its smallness. But when multiplied across millions of years, it becomes ocean-opening, mountain-building power. You let your mind stretch to that scale again. No hurry. No strain. Just distance and time working together. Where three plates meet, special junctions form triple points like the corners where three tiles touch. These places are dynamically balanced, each boundary adjusting to the others. Geometry appears in geology. Angles and forces find compromise. Even plate interiors are not entirely quiet. They flex slightly. They store stress. But most dramatic activity prefers the edges, the seams of the puzzle where interaction is unavoidable. You imagine running your finger along one of these boundaries in the dark, like tracing the edge of a map you cannot see but can feel. There is texture there. Resistance. History. Future change waiting its turn. And yet, for most moments of your life, none of this interrupts your day. The motion is too slow to notice. The puzzle shifts without disturbing your sleep, your meals, your conversations. Planetary change does not always announce itself. Often, it proceeds with the politeness of deep time. You might find that reassuring. Not all powerful things are loud. Not all transformation is sudden. You rest again in your body and picture your bed as a small boat, not on water, but on a plate of stone hundreds of kilometers wide. Around you, millions of others rest on the same moving platform. Cities glow at night atop drifting crust. Forest roots grip traveling ground. Shorelines ride forward into the future grain by grain. The puzzle is not trying to finish itself. It is not solving toward a final picture. It is alive in rearrangement. And as you grow more comfortable with these great fitted pieces, you begin to wonder what invisible force is patient enough, steady enough, and warm enough to keep them all in motion from far below you. Let your attention drift downward now, below soil and stone, below aquifers and buried roots, below the deepest minds humans have ever carved. You travel not with speed, but with imagination, a slow sinking through layers of history pressed into rock. Each layer a page. Each page a memory. And beneath them all, warmth. Not fire in the familiar sense. Not open flame. But stored heat, ancient, persistent, and patient. You picture Earth not as a cold stone sphere, but as a body that still carries its birth warmth. Long ago, when the planet formed from colliding fragments in the early solar system, gravity pulled material inward with enormous force. That pressure generated heat, immense heat, enough to melt much of the young world. Though billions of years have passed, some of that energy still remains, like embers deep in a long-burning hearth. There is another source too, a quieter one. certain elements inside Earth slowly change over time through a natural process called radioactive decay. As their atoms shift, they release energy in tiny pulses. One pulse is small, but spread across the vast volume of the planet, across unimaginable spans of time, the effect is steady and significant. A background glow of warmth from within the rock itself. You do not need to memorize the term. You can simply feel the idea. Earth generates some of its own heat, softly and continuously. As you drift deeper in your mind, pressure increases. Rock above presses downward with tremendous weight. Temperatures climb. Materials behave differently here. Stone is no longer brittle like surface rock. Under enough heat and pressure, it becomes capable of very slow flow. This may sound strange at first, rock that flows, but you already understand the principle. Glass looks solid too, yet over centuries it can subtly deform. Ice, when thick enough, creeps downhill as a glacier. Even metals can bend if stress and time work together. Solidity is not a fixed trait. It depends on conditions and patience. In Earth's upper mantle, the thick layer beneath the plates rock is hot enough and pressured enough to behave like an extremely thick paste. Not liquid, not molten, but ductile, able to change shape slowly without cracking. If you could watch it for 1,000,000 years, you would see motion like the turning of a heavy, slow river. You imagine honey in winter, barely moving when poured. Now imagine honey 1,000 times thicker, moving 1,000 times slower. That is closer to the pace of mantle flow. Heat is the guide of this movement. When material deep below becomes slightly warmer, it also becomes slightly less dense. Not dramatically, just enough. And less dense material tends to rise through denser surroundings, the same way warm air rises through cool air. The ascent is gentle. Millimeter by millimeter. Century by century. As warmer rock rises, it transfers heat upward. Eventually it cools slightly and becomes denser again, beginning a slow return downward. Over immense spans of time, this creates circulating patterns, convection currents, though the word current here means something far slower than any ocean flow. You can think of it like a lava lamp moving at the speed of mountains growing. These convection patterns are not neat circles. They are complex, branching, evolving. But their effect is profound. They help move heat from Earth's interior toward the surface. And as they shift and press against the underside of the tectonic plates, they contribute to plate motion itself. Not like a conveyor belt with gears and rollers. More like a set of slow nudges. Gentle pushes. Gradual traction from below. You rest with that image, continents guided by warmth they never feel. The temperature difference between deep mantle and surface crust is one of the great drivers of geological change. Heat wants balance. Energy flows from warmer regions to cooler ones whenever pathways allow. This is a basic rule of physics, as universal as gravity. You feel it when a hot drink cools in your hands. The planet feels it across thousands of kilometers of stone. Some places allow heat to travel upward more easily. Where crust is thinner, or stretched, or fractured, warmth approaches closer to the surface. There, volcanic activity is more likely. There, new crust may form. Elsewhere, thick stable crust slows the escape, and the surface remains comparatively quiet for long ages. You begin to sense a theme, variation with inconsistency. The same underlying process, expressed differently depending on local conditions. Even the deepest drilled holes by humans, impressive as they are, barely scratch the crust compared to the total thickness of Earth. Almost everything we know about deeper layers comes indirectly, from seismic waves, from laboratory experiments on minerals under pressure, from careful modeling. Science listens to echoes and infers the shape of hidden rooms. When earthquakes occur, they send vibrations through the planet. These waves travel at different speeds through different materials. By measuring how they bend, reflect, and delay, scientists map the interior much like doctors use ultrasound to see inside a body. No need to open it fully. Motion reveals structure. You might enjoy that parallel learning through listening. The deeper you imagine going, the more unified the story becomes. Heat, pressure, density, motion, all linked. None acting alone. A system, not a collection of accidents. And yet, nothing rushes. The mantle does not boil. The crust does not skate wildly. The forces are strong but restrained by scale. Distance stretches time. Thickness slows change. The result is a planet that evolves without hurrying. You breathe in slowly and imagine warmth rising through layers of stone like a thought rising through sleep. By the time it reaches the surface, it may appear as a volcanic eruption, a spreading ridge, a lifted plateau, but its journey began far below, long before any sudden event. Causes are often quiet. Effects are sometimes loud. But the roots of change are usually patient. You rest again in your present moment, feeling the contrast between your quick heartbeat and Earth's deep tempo. Your life moves in years and minutes. The mantle moves in millions of years and kilometers. Neither scale is wrong. They simply belong to different songs. And as you settle into that layered rhythm, surface calm above, thermal motion below, you begin to drift toward the places where rising heat finds openings, where plates slowly pull apart, and where new ground is quietly born in the dark. You let your awareness travel now to a boundary that does not collide, does not scrape, does not crush, but gently opens. A place where the planet slowly makes room for itself. Where two great plates move away from one another with patient certainty, like hands gradually unclasping. There is no tearing sound. No sudden split. Only distance growing grain by grain. These places are called divergent boundaries, though you do not need the term to feel the meaning. You can simply picture a seam that widens. A line that becomes a gap. A quiet invitation for something new to rise. Most of this opening happens far from human eyes, deep beneath the oceans. Along underwater mountain chains, ridges that circle the globe like stitched seams on a blue garment, plates drift apart. The seafloor there is not flat but gently elevated, warmed and buoyed by heat from below. You imagine hovering in the dark ocean depths. No sunlight reaches here. The water is heavy and still. And yet beneath the seabed, change is underway. As plates separate, pressure on the hot mantle rock below is slightly reduced. That small release allows some of the rock to melt. Not because it becomes hotter, but because pressure drops like ice beginning to melt when squeezed conditions relax. The melt forms magma, lighter than the surrounding solid rock, and it begins to rise. It does not rush. It seeps upward through cracks and pores, following pathways of least resistance. Eventually it reaches the spreading center, the opening between the plates, and cools there, forming new crust. You can think of it like slow breathing. The plates inhale apart, and the planet exhales new stone. This new crust is usually basalt, a dark, dense volcanic rock rich in iron and magnesium. It cools quickly when it meets cold ocean water, solidifying into fresh seafloor. Layer by layer, ribbon by ribbon, the ocean floor grows outward from the ridge. Creation does not always happen in sunlight. Much of Earth's building occurs in darkness and pressure, without witnesses, without sound. If you could speed up time and watch from above, you would see symmetrical stripes forming on both sides of the ridge, equal growth in opposite directions. This symmetry was one of the great clues that helped humans understand plate motion. The rocks record magnetic patterns as they cool, like tiny compass needles frozen in place. Because Earth's magnetic field has reversed many times in the past, these reversals appear as matching bands on either side of spreading ridges, a barcode written in stone. You rest with that image, the planet keeping records without paper. The spreading is slow. Very slow. Perhaps a few centimeters each year. About as quickly as grass grows. But over millions of years, it is enough to build entire ocean basins. The Atlantic Ocean itself is widening this way, little by little, as new crust forms along the mid-Atlantic ridge and pushes older seafloor outward. You are used to thinking of oceans as ancient and unchanging. But much of the ocean floor is younger than the dinosaurs were. Compared to continental rocks, which can be billions of years old, seafloor is often youthful, recycled, renewed, replaced. There is something comforting in that renewal. A reminder that the planet has ways of refreshing its surface. At some spreading centers, volcanic activity rises above sea level, creating islands. Iceland is one such place, a visible expression of a divergent boundary, where ridge meets air. There, you can walk on land that is geologically newborn, formed from repeated flows of magma meeting cold atmosphere instead of cold sea. You imagine standing there in gentle fog, knowing the ground beneath your feet is younger than many trees. Not all divergent boundaries lie under oceans. Some cut through continents themselves. In these places, the crust stretches and thins. Valleys form. Faults drop blocks of land downward between uplifted shoulders. This is called a rift, a word that simply means a split. The East African Rift is one example, where a continent is slowly beginning to part. Lakes fill the low places. Volcanoes appear along the stretched zone. If spreading continues for millions of years, a new ocean may one day form there. You let that timescale relax your thoughts. No urgency. No deadline. Just process. Stretching crust behaves differently than compressed crust. Instead of folding, it fractures. Instead of thickening, it thins. Heat rises closer to the surface. Volcanic pathways become easier to open. The landscape reflects the underlying tension: long valleys, linear lakes, aligned vents. But even here, the motion is measured. Continental rifting proceeds at a pace too slow for daily notice. Generations pass between measurable changes. The planet is never in a hurry. You breathe slowly and consider the paradox. Pulling apart can be creative. Separation can be constructive. Space can be fertile. When plates diverge, they do not leave emptiness behind for long. Earth does not tolerate surface voids easily. Magma rises to fill the gap, cools, and becomes structure. The opening becomes foundation. This is a gentle lesson written in geology. Absence invites formation. Hydrothermal vents often appear along mid-ocean ridges, where seawater seeps down through cracks, warms near magma, and rises again carrying dissolved minerals. When the hot fluid meets cold ocean water, minerals precipitate into chimney-like structures. Around these vents, entire ecosystems thrive without sunlight, powered not by photosynthesis but by chemical energy. Life finds a way even here, in darkness, heat, and pressure. You might like that thought that even in hidden places of separation, life gathers. The ridges themselves are not straight lines but wandering paths, offset by fractures where segments slide slightly past one another. The geometry is complex but balanced. Motion distributes itself through networks of adjustment. Nothing about this process is violent by default. It is steady, persistent, rhythmic. Eruptions happen, yes, but they are part of a longer calm pattern of renewal. Most magma cools quietly below the surface, adding thickness from underneath like careful stitching. You return your awareness to your resting body and feel how natural it is to expand your lungs, to create space inside yourself with each breath. Divergent boundaries are like that planetary inhales, openings that allow fresh material to enter the structure. The crust you stand on may once have risen from such a place, long ago, carried sideways over ages to reach its present position. Ground has a birthplace, even if it has traveled far since then. And as you grow comfortable with these quiet openings, these patient scenes of creation, your thoughts begin to drift toward the opposite meeting, where plates do not separate, but move toward one another, and where pressure slowly learns how to rise. You let your mind travel now to a different kind of boundary, not where the planet opens, but where it gathers itself inward. A place of approach. A place of meeting. Two vast plates drifting across the mantle finally come face to face, not suddenly, not violently at first, but with the inevitability of slow geometry. You picture two rafts of stone moving across a dark, warm sea of deeper rock. For millions of years they wander. Then, gradually, their edges draw near. The distance between them narrows by the width of a fingernail each year. No sound announces it. No clock chimes. And yet the meeting is certain. This is a convergent boundary, though again, you can feel it without naming it. It is a closing space. A long embrace of continents. When plates meet, their behavior depends on what they carry. Some plates hold thick, buoyant continental crust. Others carry thinner, denser oceanic crust. Density matters here, like the difference between light wood and heavy stone placed on water. The denser material tends to sink beneath the lighter when they press together. You imagine two sheets moving toward each other, one slightly heavier, one slightly lighter. The heavier edge begins to bend downward, slipping beneath the other into the warmer mantle below. This sinking is called subduction, but you can think of it as a slow dive. A return journey for old seafloor back into Earth's interior. The descending plate does not drop freely. It slides at an angle, guided by gravity and pressure, scraping along the underside of the overriding plate. Friction builds. Rock deforms. Fluids trapped in minerals are released by heat and pressure, rising into the mantle above and helping generate magma. That magma may eventually feed volcanoes at the surface, forming arcs of mountains that trace the boundary like glowing punctuation marks. So in one long motion, descent below, rising above, the planet recycles itself. Ocean floor is created at spreading ridges and consumed at subduction zones. A slow breathing cycle. Inhale at divergence. Exhale at convergence. You rest with that symmetry. Where an oceanic plate meets a continental plate, subduction is common because oceanic crust is usually denser. The sinking slab pulls downward, sometimes dragging the rest of the plate behind it like a heavy anchor. Offshore trenches form deep, narrow valleys in the seafloor, marking the place where the plate bends and begins its descent. These trenches are among the deepest places on Earth, carved not by rivers but by tectonic geometry. Above the descending slab, the overriding continent may host a chain of volcanoes fed by melting processes below. The Andes along the western edge of South America are one example, mountains born from long subduction, rising layer by layer through eruptions and uplift. You imagine standing there across ages, watching peaks grow grain by grain. But sometimes two continents meet instead, both thick, both buoyant, both resistant to sinking. In that case, neither plate easily subducts. Instead, they press together and crumple. The crust shortens and thickens. Layers fold and fault. Rock that once lay horizontal is bent into arches and troughs. The surface lifts. Mountains are not always pushed up from below like pimples on skin. Often they are squeezed up from the sides, like a rug wrinkling when compressed. You can picture placing your hands on opposite ends of a cloth and gently pushing inward. Ridges rise. Valleys form between them. Nothing is added from underneath, shape comes from shortening and stacking. That is how many great mountain belts form. The Himalaya are a living example, the ongoing result of the Indian plate pressing into the Eurasian plate. The motion continues today. The uplift continues today. The highest peaks on Earth are not finished. They are still growing, even as erosion wears them down. Growth and wearing away happen together, like inhaling and exhaling at once. You let yourself enjoy that paradox, building and sculpting in the same breath. Pressure at convergent boundaries is immense, but it is usually applied slowly. Rocks do not simply snap. Many bend, flow, and recrystallize under heat and compression. Minerals rearrange into denser forms. New textures develop. Metamorphic rocks are born, stones transformed not by melting, but by stress and temperature. Limestone becomes marble. Shale becomes slate. Basalt becomes schist or gneiss under the right conditions. Transformation without liquefaction. Change without disappearance. Deep below mountain belts, roots of thickened crust extend downward like keels beneath ships. These roots help support the high elevations above, balancing mass within the softer mantle. Mountains are not only tall upward, they are deep downward too. Height has hidden structure. Earth favors balance in the long run. Added weight sinks slightly. Removed weight rebounds. This slow adjustment is called isostasy, but you can think of it as floating equilibrium. Like icebergs showing only part of their volume above water, mountain ranges reveal only part of their total thickness above the surface. At convergent boundaries, earthquakes are common companions. As plates press together, they do not slide smoothly. Edges lock due to friction. Stress accumulates silently. When resistance is finally overcome, stored energy releases as seismic waves. But tonight you do not linger on the suddenness, only on the preparation. The long loading of a spring. The patient storing of force. Even dramatic events are built from quiet accumulation. You imagine the meeting of plates not as violence, but as persistence. A long conversation in pressure. A negotiation written in stone layers. Every fold a sentence. Every uplift a paragraph. Sediments that once rested on ancient seafloors may be caught in the collision zone and lifted high into mountains. Marine fossils appear at great altitude, shells embedded in limestone near summits, gentle reminders that geography travels through time. Today's ocean floor can become tomorrow's mountaintop given enough compression and patience. Nothing is locked to its current role forever. You return to your breath and notice how your own body handles convergence. Muscles press, bones support, tissues adapt. Pressure in biology, as in geology, can strengthen structure when applied within limits and over time. Not all force is destructive. Some force is formative. The planet does not rush its architecture. Convergent boundaries are slow workshops where landscapes are shaped through endurance. Peaks are drafted. Plateaus are raised. Crust is thickened like layered fabric. And as you grow calm inside this image of gathering and lifting, of edges meeting and mountains rising, your thoughts begin to drift toward another kind of boundary, not opening, not colliding, but sliding, where plates move side by side and tension learns how to wait. You arrive now at a boundary that does not open like a seam or rise like a wrinkle, but glides. A place where two tectonic plates move alongside each other, shoulder to shoulder, edge to edge, traveling in different directions without trying to climb or dive. Their meeting is not an embrace and not a separation, it is a passing. You can imagine two enormous books resting flat on a table, their covers touching. Slowly, gently, you slide one forward and the other backward. The contact remains, but the positions change. The surfaces resist, catch, release, and catch again. This is the feeling of a sliding plate boundary, what scientists call a transform boundary, but tonight it is simply a shared edge in motion. Nothing new is made here. No fresh crust rises. No old crust sinks. The surface is conserved, but rearranged. The change is in position, not presence. And yet, these edges are rarely smooth. Rock against rock is rough at every scale. Even surfaces that appear polished contain tiny ridges and interlocking points. When two plates try to slide past one another, these irregularities create friction. They grip. They hold. They resist motion even while the deeper driving forces continue to push. So the plates do something very human, they try to move, fail, and store the effort. You picture tension like a stretched string. The motion does not stop, it is postponed. Stress accumulates invisibly along the boundary, distributed through networks of fractures and locked segments. Years pass. Decades. Sometimes centuries. The surface landscape may appear calm: hills, roads, rivers, all undisturbed to the casual eye. But underground, resistance and motion are negotiating. You might find it soothing to know that not all movement is continuous. Sometimes progress happens in pauses and releases. sometimes energy weights. Along sliding boundaries, the crust is often cut by faults, fractures where blocks of rock have moved relative to each other. Some faults are simple and single. Others are branching systems, braided and complex, spreading motion across a wider zone. The famous San Andreas Fault in California is one such boundary, not a single crack, but a network of connected breaks accommodating the sideways journey of the Pacific Plate past the North American Plate. You imagine tracing such a fault line with your finger across a map, a long, subtle curve marking where two giant travelers pass in opposite directions. Because plates are not perfectly rigid and faults are not perfectly straight, motion distributes unevenly. Some segments creep slowly, sliding a few millimeters each year without much resistance. This is called fault creep, a gentle, steady adjustment that releases stress gradually. Other segments remain locked, building tension like a drawn bow. Locked does not mean frozen forever. Only delayed. You can think of friction here like clasped hands. Muscles press. Skin grips. For a while, nothing moves. Then the grip loosens and the hands shift suddenly into a new position. The stored effort becomes motion all at once. In geology, that sudden shift sends vibrations outward, seismic waves, and the ground trembles. But tonight, you stay with the slow part, the holding phase. The quiet accumulation. The patience of pressure. Friction is not an enemy in this story. It is a keeper of timing. Without friction, plates would slide too freely, too constantly. With friction, motion is portioned. Energy is saved and then shared in pulses. The planet meters its adjustments. At sliding boundaries, surface features often show the sideways story. Rivers may be offset where their channels cross a fault once straight, now shifted. Fences, roads, and rock layers can be displaced over time, like lines in a drawing gently misaligned. Valleys may form along the fault trace, worn by erosion along fractured rock. Linear ridges and troughs appear, marking the path of long-term shear. Shear, that is the technical word for sideways stress, but you can feel it simply as parallel force in opposite directions. Like rubbing your palms together slowly. Warmth appears. Resistance speaks. Sometimes, where the fault bends slightly, local compression or extension occurs. A small curve in the boundary can create uplifted hills or sagging basins nearby. Even a sideways system has pockets of vertical change. Geometry shapes outcome. You let yourself appreciate how sensitive the system is to angles and textures. A small irregularity, multiplied across kilometers and centuries, becomes a landscape feature. Not all sliding boundaries sit on land. Many lie beneath oceans, connecting segments of spreading ridges. There, they offset the ridges like steps in a staircase, allowing plates to spread while keeping overall geometry balanced. These oceanic transform faults are usually quiet at the surface, hidden by depth and distance, but they play an essential role in plate motion like joints in a moving frame. The planet prefers networks to single lines. Redundancy to isolation. You notice a pattern now across all boundary types you have visited. Divergent boundaries create new crust. Convergent boundaries recycle and lift it. Sliding boundaries rearrange it. Creation, transformation, repositioning, three verbs of a living surface. None require haste. You return to your breath and feel how your own body handles stored energy. A held inhale contains potential. A pause before speaking gathers intention. A muscle held ready contains force without movement. Nature repeats principles across scale. Storage and release. Grip and glide. At sliding boundaries, most of the story is invisible day to day. That invisibility can feel unsettling if you expect constant signs. But it can also feel comforting if you trust long processes. Quiet does not mean inactive. Silence does not mean empty. Stillness can be preparation. You rest inside that idea that waiting is also a form of motion. And as you grow more at ease with these sliding edges and their patient friction, your thoughts begin to lean toward what happens when stored energy finally travels outward, not as shifting rock, but as waves moving through the planet like messages in motion. You rest now beside one of Earth's most misunderstood voices, the earthquake. Not as a disaster in headlines, not as fear in memory, but as a physical language. A way the planet redistributes stored energy. A message sent through stone using motion instead of sound. You begin with calm, with breath, with the understanding that nothing in geology happens without a long preface. An earthquake is not a sudden idea. It is a long sentence reaching its final word. Deep along a fault, where plates press, pull, or slide, rock surfaces catch on one another. Friction holds them in place even while deeper forces continue to move. Stress builds quietly, invisibly, like tension in a drawn bowstring. The rocks deform slightly, storing elastic energy, bending at microscopic scales. Elastic means something simple and gentle, able to flex and spring back. Like a wooden ruler bent just enough to hold energy without breaking. The crust behaves this way too, within limits. It is stronger than it looks, and more flexible than it seems. When the stored stress exceeds the strength of the locked section, the rock finally slips. Not everywhere at once, but along a patch, a rupture zone that suddenly gives way. The two sides shift into a new position, often only by centimeters or meters. The movement is small in distance, but large in consequence, because the release is fast. Energy that took decades or centuries to store may release in seconds. That release sends waves outward through the surrounding rock. Not cracks racing through the ground, but vibrations, oscillations, pulses of motion that travel like ripples on a pond. These are seismic waves. They are the earthquake's true voice. You imagine dropping a pebble into still water at night. Rings spread outward in widening circles. Now imagine that happening inside the earth, in 3 dimensions, through solid material. The waves move not just across a surface, but through volume, through layers, through boundaries, through the curved body of the planet. There are different kinds of seismic waves, each with its own personality. The first to leave the rupture are primary waves, or P waves. You can think of them as compression waves, push and pull pulses that squeeze and release the material they travel through. Like gently pressing and relaxing a spring. The motion is parallel to the direction of travel. These waves move fastest and arrive first at distant sensors. They can travel through solids, liquids, and gases, because all these materials can be compressed. You might picture them as quiet knockings moving through the planet's bones. Next come secondary waves, or S waves. These move differently. Instead of compressing and expanding, They shake material side to side or up and down, motion perpendicular to their direction of travel, like ripples moving along a rope when you flick it. This shearing motion requires rigidity, so S-waves can travel only through solids, not liquids. When they reach liquid layers, they fade. Already, you can feel how waves become informants. Their behavior reveals what they pass through. After the body waves, P and S, come surface waves, which travel along Earth's exterior layers. These are often slower but can produce larger ground motions near the surface. They roll and sway, sometimes in looping patterns, sometimes in side-to-side sweeps. They are shaped by the structure of the crust they move through, amplified or softened by local geology. But tonight, you do not dwell on damage. You stay with communication. Seismographs, delicate instruments designed to sense motion, listen continuously. They do not sleep. When seismic waves arrive, they record the timing and shape of each vibration. From many stations across the globe, scientists compare arrival times and wave patterns to locate the source and understand the rupture. It is triangulation through listening. No one sees the fault move at depth, but the waves report it faithfully. You may like the gentleness of that learning through echoes. Earthquakes vary widely in size. Most are so small you never feel them. Tiny adjustments happen every day across the planet, microslips relieving small pockets of stress. Only larger releases produce motion strong enough to notice without instruments. The scale scientists use to describe earthquake size is based on energy, how much elastic strain is released, not simply how much the ground moves at one location. Energy scales are logarithmic, which means each step upward represents many times more energy released. A modest increase in magnitude reflects a large increase in physical release. But again, you hold this lightly. Numbers are not the point tonight. Process is. You imagine stress like slowly filling a reservoir behind a dam. Small leaks occur regularly. Occasionally, a gate opens wider and more water flows at once. The system is not malicious. It is mechanical. After a major rupture, nearby sections of the fault may readjust. Smaller earthquakes called aftershocks occur as the crust settles into its new stress balance. Not echoes, exactly, but follow-up notes in the same geological conversation. Even the distribution of aftershocks teaches scientists about fault geometry and frictional behavior. Patterns reveal structure. Sometimes earthquakes occur away from plate boundaries, within plate interiors. These intraplate events often reactivate ancient faults, old weaknesses preserved in the crust like healed scars that can still feel pressure. The plates are mostly rigid, but not perfectly uniform. History leaves textures behind. You breathe slowly and consider how often the word sudden is used for earthquakes. And yet, nothing about their preparation is sudden. They are the visible moment of a long invisible buildup. A release, not a beginning. The planet is not angry when it shakes. It is adjusting. Waves from large earthquakes can travel through the entire Earth and be detected on the far side of the globe. Some reflect off internal boundaries. Some refract, bending as they pass through materials of different density. By studying these paths, scientists map Earth's inner layers: crust, mantle, outer core, inner core. The discovery that the outer core is liquid came partly from observing that S waves do not pass through it. So each earthquake, even a distant one, becomes a probe, a brief flash of illumination inside an otherwise unreachable interior. You might find that beautiful disturbance creating knowledge. You return your attention to your resting body and notice your own internal signals. Your heartbeat sends waves through tissue. Your nerves send pulses through networks. Motion carries information in living systems too. The Earth is not alive in the biological sense, but it is dynamic, responsive, structured, communicative through physics. You are listening now instead of fearing, observing instead of bracing. And as the idea of seismic waves settles into something more like language than threat, your thoughts begin to drift toward places where pressure does not only shake the ground, but sometimes melts it, opening pathways upward where the deep interior briefly meets the open air. You arrive now at one of Earth's most dramatic features, and you approach it gently. Not as a spectacle, not as a threat, but as an opening, a window through which the deep interior briefly touches the surface. A volcano is not a wound in the planet. It is a passageway, a pressure valve, a conversation between layers. You begin by softening the image. Remove the sudden explosions you may have seen in films. Set aside the urgency of headlines. Instead, picture a quiet mountain with a hidden channel beneath it, a vertical pathway shaped by heat, buoyancy, and time. Deep below the crust, rock is usually solid, even when hot. But under certain conditions, reduced pressure, added fluids, or increased temperature, parts of it melt. This melt is magma, rock in liquid form mixed with crystals and dissolved gases. It is not an endless underground ocean of fire, but localized pockets and reservoirs, formed where physics allows. Magma is lighter than the surrounding solid rock, just as warm air is lighter than cool air. Because of that small difference in density, it tends to rise. Slowly. Patiently. It moves through fractures and porous zones, gathering in chambers where pathways narrow or resistance increases. You can imagine it like sap rising inside a tree, not forced, not rushed, simply guided upward by natural gradients. Volcanoes often appear near plate boundaries because those are places where the crust is stressed, fractured, or interacting with unusual heat conditions. At divergent boundaries, where plates pull apart, decompression melting helps magma form and rise. At convergent boundaries with subduction, descending plates release water into the overlying mantle, lowering melting temperatures and encouraging magma generation there. Different paths. Same principle, conditions change, rock melts, buoyancy lifts it. Some volcanoes are frequent and gentle. Others are rare and powerful. The difference often lies in magma composition and gas content. Thin, low-viscosity magma, meaning it flows easily, allows gases to escape gradually. Eruptions tend to be calmer, with flowing lava that spreads and cools like thick syrup poured over land. Thick, high-viscosity magma traps gases more effectively. Pressure builds longer. When release comes, it can be more explosive. Viscosity is simply resistance to flow. Honey has higher viscosity than water. Cold honey higher than warm honey. Magma follows similar rules, shaped by chemistry and temperature. You do not need the chemical details tonight. Only the feeling. Some melts move easily, some resist, and behavior follows texture. When magma reaches the surface, it becomes lava. The name changes with location, not substance. Above ground, exposed to air or water, it cools and solidifies into igneous rock, new crust added from below. Basalt, andesite, rhyolite, different names for different compositions, all born from molten origin stories. Creation again, through heat. Volcanoes build land in layers. A single eruption may lay down a thin sheet. Repeated eruptions stack flows, ash, and fragments into cones and domes. Some volcanoes grow broad and low with fluid lava. Others grow steep with thicker material. Shape reflects behavior across time. You imagine watching one form in extreme time-lapse, pulses of eruptions separated by centuries of quiet, a mountain assembled episode by episode. Ash, though it sounds soft, is made of tiny shards of volcanic glass and mineral fragments. It can travel far on high winds, settling over distant landscapes. In the long run, volcanic ash often enriches soil with nutrients released from fresh minerals. Many fertile regions of the world sit on old volcanic deposits. Vineyards, forests, and farms grow where eruptions once laid gray blankets. Destruction and renewal share a doorway. Gases dissolved in magma also play a role: water vapor, carbon dioxide, sulfur compounds. As magma rises and pressure decreases, these gases come out of solution, forming bubbles, like fizz appearing when you open a bottle of sparkling water. Expanding gas helps drive eruptions, fragmenting magma into ash or propelling lava upward. Gas is motion's amplifier. You rest with the gentleness of that analogy: bubbles rising, pressure easing. Not all volcanic activity builds tall mountains. Most of Earth's volcanic output happens out of sight, without drama. There are also volcanic systems that do not sit neatly on plate boundaries. Some form above mantle plumes, focused upwellings of hotter material rising from deeper regions. These plumes can create chains of volcanoes as plates drift overhead. The Hawaiian Islands are an example of volcanic trail recording plate motion like footprints across the Pacific. In that way, volcanoes can become markers of movement. Timestamps written in lava. Between eruptions, volcanoes often rest for long periods. Magma cools underground. Conduits solidify. Landscapes green over. Lakes fill old craters. Quiet returns. A volcano is not always active. It is a system with phases: charging, releasing, sleeping. You might like that rhythm: activity nested inside rest. Scientists monitor volcanoes with many instruments: seismometers listening for small quakes caused by moving magma, GPS sensors detecting ground swelling, gas analyzers sampling emissions, satellites measuring heat and shape. The goal is not prediction with certainty, but awareness of change. Listening again, always listening. The deeper truth beneath every volcano is simple and steady: heat moves upward when pathways allow. Pressure seeks balance. Material cycles between depths and surface across ages. A volcano is not separate from plate tectonics, it is one expression of the same planetary engine you have been exploring all along. You place your awareness once more on your breath and imagine it as a tiny volcano of air rising, releasing, settling. A soft cycle. A safe one. Fire becomes land. Ash becomes soil. Rock becomes mountain. Then slowly, through weather and time, mountain becomes sediment again. Cycles within cycles, all powered by gradients and gravity. And as you grow calm beside these windows into the deep, your thoughts begin to drift outward across the wide ocean floors, where crust is born, travels, ages, and one day may return below, opening and closing basins like slow-turning pages. You let your mind float now over the vast, dark expanse of the oceans. Their surface seems constant, serene, and timeless. Yet, beneath that placid blue, motion continues. Oceans are not eternal. They have a history of opening, spreading, shrinking, and disappearing, a rhythm dictated by the plates below. Long ago, the Atlantic Ocean did not exist. Neither did the Pacific as we know it. Continents were once closer together, sometimes forming massive supercontinents. Landlocked seas occupied spaces that are now open water. Islands were submerged, and mountains sank beneath waves. Earth rearranges itself slowly, like a grand game of chess played over millions of years, with pieces moving so gradually that a single lifetime cannot perceive it. You drift along the imaginary surface of these ancient seas, letting your awareness sink beneath the waves. The seafloor is much younger than the continents. Rocks beneath your imagined feet may be only tens of millions of years old, whereas continents often carry billion-year-old cores. New seafloor is born where plates pull apart along mid-ocean ridges, where magma rises and cools, forming basaltic crust. Here, the ocean is young, a cradle of motion. This process is subtle yet relentless. As plates spread, older seafloor moves away from ridges, carrying water with it. Entire basins grow wider, rivers of rock beneath the waves pulling continents further apart. In some places, the expansion continues even today, adding kilometers of new seafloor each century. You imagine watching the ocean's birth through time-lapse, ridges widening, crust forming, currents flowing above, sediments slowly settling. It is a serene performance, with a rhythm far slower than the tide, yet powerful enough to shape continents. And just as oceans open, they can close. Subduction zones are the closing act, where older oceanic plates descend into the mantle, slipping beneath other plates. Trenches form at these boundaries, narrow, deep canyons marking where one plate begins its descent. The Pacific Ocean is slowly shrinking in some regions because its margins are crowded with subduction zones. Water does not prevent the process. The deep blue only covers it, softening the drama with quiet opacity. Even the deepest parts of the ocean are part of this movement. Trenches, abyssal plains, mid-ocean ridges, fracture zones, all connected in a slow ballet. Currents above the seafloor do not drive the tectonics, but they reveal the topography created beneath. The seafloor's motion is patient, deliberate, and invisible to the human eye on a daily scale. You imagine a tiny grain of sediment falling through the water column, finally resting on the seafloor. Over millions of years, it may be carried sideways as the crust spreads, eventually drawn into a subduction zone, returning to the mantle. Matter cycles in ways too slow for direct perception. Water carries the illusion of stability, yet underneath, the planet is in constant rehearsal. Oceans are also repositories of memory. Magnetic stripes etched into the seafloor record reversals of Earth's magnetic field. Layer upon layer of volcanic rock, altered by chemical changes, fossilized microorganisms, and sediments, keep a record of changing climates, ocean chemistry, and tectonic shifts. The water above does not erase these stories, it protects them. You float above the abyssal plains and imagine the slow movement of sediments, the gentle undulations of the ocean floor. Hydrothermal vents release mineral-rich water, providing life where sunlight cannot reach. Life thrives in pockets where geology and chemistry intersect, all a part of the dynamic dance of oceans opening and closing. Some ocean basins will eventually vanish entirely. The Tethys Ocean, once vast between Gondwana and Laurasia, has long been consumed, its remnants folded into mountains like the Alps and Himalayas. The spaces that were once filled with water are now crustal scars, reminders of previous arrangements. Oceans are temporary, beautiful chapters in Earth's long story. You let your thoughts dwell on the transient nature of these waters. The ocean is both young and old, still expanding in some places while shrinking in others. It is a body in motion, always adjusting to the subtle push and pull of plates below. Water may cover motion, but it cannot stop it. The rhythm of divergence and convergence dictates the ocean's shape, size, and life within it. In some places, mid-ocean ridges rise high enough to create islands, volcanic arcs, or shallow seas. In others, trenches deepen into shadowed abysses. The ocean surface may appear uniform, yet the crust beneath moves like a living, breathing skin. You imagine yourself as a tiny observer floating above these changes, able to perceive the grand narrative unfold in quiet, gradual increments. The ocean also teaches patience. The motion beneath it is invisible day to day, yet over millions of years, it shapes continents, forms mountains, creates trenches, and opens new seaways. Your perception of permanence is challenged by the slow scale of geologic time. Waves lap on the shore. Currents drift. Yet the true motion is below, unseen, unstoppable. You reflect on your own life alongside this vast, slow dance. Moments appear fleeting, yet they are threads woven into longer arcs. Small changes accumulate. Invisible movements prepare for visible outcomes. Like a tiny ripple that eventually joins a river, or a small thought that shapes a future decision, motion in time is cumulative. You might feel reassured knowing that even as oceans shift and continents wander, Earth maintains balance. The creation of new crusted ridges is balanced by subduction elsewhere. Plates are constantly reorganizing, but mass and energy are conserved. The ocean covers this motion, but it is not removed. The planet is patient, deliberate, and efficient. You imagine floating once more over the great ridges and trenches, sensing the rhythm of expansion and consumption. The ocean floor is alive with activity, moving and folding and slipping slowly beneath the waves. It is a story written in stone, magma, and water, unfolding invisibly, rhythmically, endlessly. And as you drift gently across these waters, across basins appearing and disappearing, your thoughts begin to rise toward the surface of the next grand scale of movement, where continents gather into vast unions, assembling supercontinents and leaving behind scars that record Earth's long memory. You allow your imagination to stretch across eons, farther than the memory of any human, into the slow, patient rhythms of deep time. The land beneath your feet is not as permanent as it seems. Continents, those enormous islands of stone, are wanderers, travelers across the molten underworld, gathering and dispersing over hundreds of millions of years. You picture the Earth's surface as a stage for long, deliberate choreography. Today's continents are actors on a scene shaped by unseen hands, moving inch by inch, carried by currents in the mantle, merging, rifting, drifting. Their journeys are imperceptible to a single human lifespan, but over ages, their motion tells stories written in the language of rock. Once, all continents were united in a single supercontinent, Pangaea. You imagine it as a vast quilt, stitched from all today's separate lands, covering the globe like a blanket of stone. It stretched from pole to pole, oceans curled at its edges, and winds circled in patterns unknown today. Life thrived upon this singular landmass, oceans surrounding, seas threading through, yet the earth beneath was in motion, quietly preparing for change. The forces that gathered these continents were the same forces that now move them apart. Plates collided, suturing edges, folding crust into mountains, welding crust together over immense scales. Subduction zones consumed ocean basins. Magma welled up in seams, adding new material. Over time, continents converged into unity. You breathe slowly, imagining the scale. One continent meeting another is a small act in the present moment, yet the total gathering of supercontinents is a process of hundreds of millions of years. The motion is gentle, almost imperceptible, yet unstoppable. And then, inevitably, Pangaea began to break apart. Rifts formed. Magma rose through weakened zones. Ocean basins opened. The Atlantic Ocean began its slow growth. You picture the landmass stretching, cracking, drifting. The once united land fractured like a page torn slowly at the edge, and the pieces began their separate journeys. Separation, like convergence, is creative. Space opens, and new features are born. The planet's memory resides in these patterns. The scars of ancient collisions appear as mountain roots, ancient belts of rock squeezed and folded in long-forgotten unions. Continental interiors preserve evidence of past assembly, minerals aligned, metamorphic rocks formed, structures repeated across ages. Supercontinents leave marks that guide the formation of new ones. Earth remembers. You float above this memory, letting your thoughts drift along ancient coastlines, imagining seas that no longer exist. Shallow continental shelves, now dry land, once hosted tides and reefs. Fossils and rock tell silent stories of previous arrangements. Geologists, in their quiet study, read these clues, learning the choreography of the past. The cycles repeat. Supercontinents assemble, then fragment. Oceans grow and shrink. Mountain belts rise and erode. Sediments accumulate, sink, and return. It is a rhythm of creation and destruction, folding time into layers of stone. Life rides upon these changes, adapting, flourishing, sometimes perishing. Earth's surface is never static, yet it is coherent, patterned, persistent. You reflect on the patience of these processes. Mountains built in collisions can last millions of years, eroding slowly into sediments that fill basins. Rifts may linger for tens of millions of years before giving rise to new oceans. Motion is slow, almost imperceptible, yet relentless. The scale dwarfs human experience, and yet you are able to perceive it gently, with imagination and thought. Supercontinents influence more than landforms. Their positions affect ocean currents, climate patterns, and biological evolution. When continents gather near the poles, ice may advance, shaping weather and ecosystems. When they cluster near the equator, shallow seas warm, life proliferates. The very arrangement of rock beneath your feet affects the atmosphere above, creating a dance between solid earth and life upon it. And you realize that this long memory, written in stone, is patient but precise. Each collision, each rift, Each plate motion is recorded in layers, in alignment, in magnetic stripes, in isotopic signatures. Rocks themselves are historians, preserving events that occurred hundreds of millions, even billions, of years ago. You rest with that image, a planet as a chronicler, keeping accounts of its own slow evolution. You watch Pangaea dissolve into Laurasia and Gondwana. Each fragment continues to move, interacting, colliding with others, forming mountain belts and basins anew. Supercontinents are never permanent, yet each leaves a legacy. Their story informs the next cycle, like chapters in a novel of stone and magma. The Earth writes and rewrites itself endlessly. And as you imagine these cycles repeating, assembling and dispersing, you notice the elegance of balance. The planet's motions obey gravity, heat flow, material properties. It is a system that regulates itself over immense time, conserving mass and energy while allowing shape, elevation, and distribution to vary. Mountains rise, oceans deepen, continents drift, all in a harmony unseen on human timescales but perceptible in imagination. You might appreciate that the world we inhabit today is only a temporary arrangement. Continents are temporary companions, oceans are fleeting seas, mountains are young or ancient depending on perspective. Nothing on the map is permanent, nothing fixed forever. The Earth is always rewriting its surface, creating and erasing, sculpting and reshaping. You let your breath match the rhythm of these cycles. A long inhale, like continents converging. A slow exhale, like rifting and oceans opening. Motion is continuous. Change is inevitable. Stability is only temporary, a pause within ongoing processes. And yet, there is beauty in that rhythm, in the deliberate, measured steps of planetary time. Even as humans perceive maps as static, the Earth beneath continues its choreography. Plate motion, mountain building, rifting, spreading, subduction, all these processes combine to form landscapes, climate, and life patterns. You sense the continuity across millions of years, the persistence of process, and the patience required to observe it. And as you settle deeper into the idea of supercontinents, their formation and fragmentation, their scars and memory, your thoughts begin to drift toward observation, toward the human curiosity that noticed patterns in the planet, that learned to read the rock, the magnetic stripes, and the fossils. The next chapter awaits you there, at the threshold where human eyes learn to see the moving world. Now, you return from the vast motions of rock, magma, and water to the minds that first noticed these hidden movements. Humans once believed that continents were fixed, mountains permanent, oceans eternal. Yet, patient observation, careful measurement, and imagination revealed the truth. The Earth beneath your feet is always traveling, shifting imperceptibly, shaping landscapes over time. You picture early observers, perhaps peering at maps or noticing similarities across distant shores. The coast of South America fits against the curve of Africa like an old puzzle, one piece sliding into another. At first glance, it seems coincidental. Yet someone paused long enough to wonder, could continents once have been connected? Could these patterns be more than chance? Curiosity acts quietly, almost like breathing, yet it drives the first spark of understanding. Fossils whispered stories too. Identical species appeared on continents now oceans apart. Mesosaurus, a freshwater reptile, left its remains in South America and Africa. How could a creature, unable to cross salty seas, appear on both lands? Slowly, evidence accumulated. patterns repeated. The planet, like a careful storyteller, left clues across its surface for those who knew how to read them. You imagine running your hands over fossilized shells and rock layers, feeling time compressed into stone. Each specimen, each formation, a letter in a larger, hidden text. The message was not obvious. It required patience, intuition, and methodical observation to decipher. Meanwhile, rocks themselves recorded motion. Magnetized minerals and basalt aligned with the magnetic field at the time of their formation. Along mid-ocean ridges, geologists discovered symmetrical stripes of reversed polarity on either side of spreading centers. Earth itself had written its diary in iron-bearing rocks, detailing the slow opening of oceans. A scientist standing at the ridge could read the history of continental drift as plainly as lines in a book. And it was not only fossils and magnetism. Mountains held ancient sutures and folds, ocean trenches preserved scars, and sediment layers archived environmental shifts. Observers combined multiple lines of evidence: paleontology, geophysics, chemistry, and mapping to perceive processes invisible to a casual glance. Earth's hidden motions became legible through careful, repeated study. Imagine the sensation of revelation. Alfred Wegener, one of the first to propose that continents drifted, faced skepticism. His ideas felt too radical at the time. Yet pieces of evidence continued to emerge. Over decades, marine surveys revealed mid-ocean ridges, trenches, and patterns of earthquakes and volcanism that aligned with his vision. What had seemed impossible became inevitable. Curiosity, persistence, and careful measurement bridged imagination and reality. You sense the rhythm of understanding growing slowly, like dawn breaking over mountains. One clue at a time. One observation at a time. No rush, no abrupt leap, only the patient assembly of knowledge. Scientists became the senses of the planet, instruments of curiosity extended across space and time. Seismology, too, provided insight. Networks of seismometers recorded tremors globally, mapping earthquakes in ways that revealed plate boundaries invisible to the naked eye. Patterns of quakes traced the edges of moving plates, highlighting subduction zones, transform faults, and spreading ridges. Vibrations, once feared or ignored, became a vocabulary for understanding motion. Energy transmitted through rock became a message, waiting for interpreters. Oceanography contributed its own voice. Detailed mapping of the seafloor uncovered ridges, valleys, and fracture zones. Deep trenches in mid-ocean mountains revealed that ocean basins were dynamic, not fixed. Sediment layers told of ancient seas, and magnetic anomalies preserved a record of spreading. Observation became a telescope into the past, revealing motions invisible in the span of a single lifetime. You imagine early explorers aboard ships, using rudimentary equipment yet gathering precise measurements. Each sweep of a sounding line, each mineral sample, each fossil, added threads to the intricate tapestry of knowledge. Slowly, the moving earth became comprehensible, not through sudden revelation, but through patient accumulation of evidence. And you realize, seeing the moving world requires both imagination and restraint. It requires the courage to entertain possibilities that seem improbable, and the discipline to verify every detail. It is a balance between dreaming and measuring, speculation and observation, curiosity and rigor. Technology amplified human perception. Satellites now track plate motion directly. GPS measurements reveal that continents drift centimeters per year, almost imperceptible to humans, yet unceasing. Earth's motion can be sensed in real time, yet it follows the same slow, deliberate rhythm that has existed for millions of years. Ancient fossils, magnetic stripes, and satellite data all speak the same truth, across time and scale. And you understand that this chapter in human understanding is ongoing. Each generation refines knowledge, builds upon previous work, notices subtler patterns, and asks new questions. Observation is a continuous conversation with the planet, one that requires patience, attention, and humility. The lesson is also personal. You, resting here, listening to this story, are part of a long tradition of curiosity. Your mind senses patterns, compares, imagines, and absorbs. You extend awareness beyond your immediate surroundings, perceiving motion at scales far beyond ordinary experience. You become a participant in the planet's slow dance, a conscious observer aware of hidden rhythms. You can see how human understanding mirrors Earth itself. Just as motion accumulates over ages before it becomes visible, knowledge builds gradually, piece by piece, until a coherent picture emerges. The same patience, the same attentiveness, the same willingness to notice subtle clues, these guide both rock and mind. And as you reflect on the long journey from unnoticed patterns to scientific insight, your thoughts begin to drift naturally toward rest. The next step is not new discovery, but a quiet return to the present, to lying on a plate that moves beneath you, to feeling the gentle rhythm of the living world supporting you. Tonight, you sleep while the earth continues its slow journey. Now, you settle into the quiet of your own space, aware that beneath the familiar floor, your room, your bed, the ground itself moves. You are resting on a tectonic plate, a vast raft of stone floating on the warm, slow-moving mantle below. The motion is imperceptible in everyday life, yet constant, deliberate, and graceful. Tonight, you allow yourself to feel this presence, this patient rhythm, without fear or concern. You imagine the plate beneath you as a gentle platform, carrying mountains, valleys, rivers, forests, and cities along its unhurried journey. Everything above the furniture, your body, the air you breathe rides this enormous slab in a shared voyage across the globe. You are part of a story that has been unfolding for billions of years, written in stone, magma, water, and life. Each movement is slow, measured, almost invisible, yet crucial in shaping the world. There is a calmness in understanding that the planet is alive in motion, not in chaos. Plates collide to form mountains, separate to open oceans, slide to release tension. Volcanoes breathe fire upward, earthquakes whisper energy through the ground, oceans shift and swell, continents drift in their majestic, patient migration. Each action is part of a balanced system, operating on timescales far beyond human perception. You rest within that understanding, letting the enormity of time fold gently around your consciousness. You notice the delicate balance that motion brings. A mountain does not simply rise, it is supported by forces deep below, by the slow adjustment of the crust, by the mantle flowing imperceptibly. An ocean basin does not remain static, it is maintained by the continual addition and removal of crust, by subduction and spreading, by a planetary rhythm that accommodates change without panic. Everything is interconnected. Motion sustains stability. Movement is not a threat, it is life, persistence, and equilibrium expressed through stone and water. Imagine yourself shrinking to the scale of a single molecule in a crystal lattice. You would feel vibrations, hear the subtle energy transfer through bonds, sense the balance that maintains integrity while allowing flexibility. Now, scale back to human perception. You lie in your bed, seemingly still, yet connected to a vast, moving system that stretches beneath continents, through oceans, under cities, and across mountains. The same principles apply: energy flows, structures adjust, systems endure. Even the smallest tremors beneath your feet, undetectable in daily life, are part of the planet's careful adjustments. The Earth releases stress gradually, conserving energy while preventing catastrophic disruption. A subtle hum of motion permeates the crust, unnoticed yet present, like a heartbeat in stone. You may feel comfort in knowing that movement is not chaotic, but regulated. It is measured, restrained, and essential. Above all, tonight, you embrace the unity of your experience with the planet's ongoing narrative. Your breathing, slow and rhythmic, mirrors the patient pulse of tectonic processes. Inhale, rise, exhale, settle. Mountains rise and fall, oceans expand and shrink, crust forms and sinks, magma flows and cools. Patterns repeat. Cycles continue. The Earth's motion is gentle when observed over the scales of your life, yet its totality is powerful, shaping the world subtly, beautifully, continuously. Your mind drifts to the history you have journeyed through, the slow breathing of a living planet, floating plates, heat that never sleeps, crust born at spreading centers, mountains raised through patient collisions, friction storing secrets, seismic waves traveling like messages, volcanoes opening pathways to the deep, oceans that appear and vanish, supercontinents forming and breaking apart, and finally, the human gaze that learned to perceive these movements. All these stories converge into the realization that the world beneath you is alive with motion, yet supportive, stable, and deliberate. You feel gratitude for this understanding. There is no fear here, only awareness. You lie on the moving plate, in the stillness of your room, part of a planetary dance that has existed long before your birth and will continue long after. You are a witness and a participant simultaneously. Your rest is supported by stone, magma, water, and the invisible hand of geologic time. You are suspended in motion that is patient, balanced, and sustaining. Consider the plate you rest upon as both stage and actor. It bears the weight of continents, oceans, forests, cities, and life forms. It adjusts imperceptibly to forces acting from below, around, and beyond it. Earthquakes, volcanic eruptions, and plate shifts are expressions of the same patient system you are resting within. Energy is conserved, stress is balanced, and motion occurs within a framework of stability. Even the most dynamic events are part of a regulated process that maintains the integrity of the Earth's surface. Your thoughts wander gently to the cycles of life, mirrored in geological cycles. Just as mountains rise and erode, as oceans advance and retreat, as continents gather and drift, life adapts, grows, and moves. You are part of a living planet, connected through motion and process, yet supported and cradled. Motion sustains rather than threatens. You can rest within this rhythm. In your imagination, you may follow the journey of your plate as it carries the land silently through the deep past and far into the future. It travels slowly, imperceptibly, but with certainty, through corridors of mantle, across faults, and along boundaries. Mountains you know as landmarks are mobile, oceans you swim in are shifting, and yet everything is stable enough for life, for cities, for you to rest safely tonight. You notice how your personal rhythms align with this vast planetary system. Your heartbeat, your breath, the gentle tension and release of muscles all resonate with the patient, slow processes beneath your feet. You are part of an intricate network of movement, balance, and energy flow. Observing it, feeling it, imagining it, you integrate with it. Your awareness softens further as the edges of consciousness blur. You lie suspended between scales, your small, intimate experience of rest and the slow, immense motions of a moving world. Tectonic plates shift, yet your space remains secure. Continents continue their quiet journey, yet you sleep peacefully. Oceans expand and contract, yet the waves above your imagined point are gentle and calm. Mountains rise imperceptibly, yet stability is maintained. Tonight, you rest with the understanding that the planet beneath you is alive in motion, yet supportive, deliberate, and predictable over long time scales. You feel a kinship with its patient energy. Your body rests, your mind drifts, the earth continues its slow dance. Motion becomes comfort, understanding becomes serenity, and the knowledge of a moving world allows you to surrender fully to rest. And as you exhale the last remnants of wakefulness, your consciousness drifts into sleep, carried by the gentle movement of continents, oceans, and mountains, a traveling world beneath you, timeless, deliberate, and endlessly alive.